Let's speak about when to use a median. As we said, a median is an exact bifurcating point. Let's take that distribution on the left, and let's say this might be, heartbeats per minute for some sort of task, or just resting heart rate per minute. And the top person has 94 beats per minute, 93, 85, etc. And then you have somebody with 30. Now, some of the best athletes have extremely low heart rates per minute, and maybe 30 is realistic. I once had students in another stats class, and two of them were Division I track athletes, and sure enough, they were both in the 40s. I don't know, 30 might be an outlier. But if I took their mean, you can see the mean is 76 plus, 76.71. Is there a problem with that? It's not a fib. It's not an out-and-out falsehood. But is 76.71 representative? You could argue that it isn't. Because 76.71 is higher than only 2 of the 7 scores. It's near the bottom. So what happened was that the 30 dragged the mean down, if you will. The number 30 had a lot of influence over that mean, and you could argue made the mean non-representative. Take a look at the distribution on the right. It's the same distribution, but what I've highlighted in red is the median. In this case where you have such an outlier, I might recommend the median. The median tells the story, frankly, a more representative story, and you'll notice, just by doing math, that the median is not influenced by outliers. If that number 30 had been 20, and maybe there are wild animals that have resting heart rates in the 20s, I imagine, say, an alligator does, in that case, the 81 would not be influenced. And that's why we use medians. If I have an extreme score or a skewed distribution, it's insulated from that. It still tells a rough stroke of the story without actually being influenced by mean. And by the way, when we report national income statistics, we report the median for that very reason. Because we have income earners out there that are making 9 figures, more than $100 million. And of course, that greatly pulls the mean income down a few thousand. Perfect example right here. We talked about this before. This number 12 that's way out there in the distance influences the mean. I don't exactly know. Did they calculate it here? No, but that number 12, there it is. Yeah, it's right on the graph. The mean is 4. You can argue that 4 is not a very representative number for the mean, because the number 12 clearly influenced it. And who knows what this is, number of children, let's say. The late Robert F. Kennedy had 11 children. So is that representative? No, it's kind of an outlier. And by the same token, there might be someone out there, if I'm gauging the number of children as 12, who knows. But in that case, of course, the median of 2.5 insulates, if you will, against those extreme outliers, whatever they may be. I also have to use the median when there's an undetermined score. So, for instance, if I have people that didn't solve a puzzle, can I ascertain the median number of minutes? Yes. I couldn't calculate a mean here, but I could calculate the median number of minutes, the number that bifurcates this distribution, since I have this undetermined value. And look at this open-ended distribution. Let's say I asked a silly question. How many times a week do you order pizza? Here's a group of 20 respondents, right? And there are 4 people that never get pizza, and I bet they're lying. And then there's 6 people that get it exactly once, and then you have somebody that gets it 5 or more times. Oh my gosh. So I've got a wide array here. I hope you'll agree that I could not calculate a mean. 5 or more could mean 10, it could mean 12, it could mean 5, right? You never know what it means. However, if we treat these numbers as continuous, I can calculate a median, and therefore it doesn't matter what 5 or more means. It's irrelevant. And by the way, by looking, and if I told you ahead of time that there are, and let me make sure I'm right about that, 5, yes, there are 20 scores here, 20 respondents that answered the question about how many times they get pizza in a week. The median might just leap off the page. I hope you'll recognize that there are 10 respondents below 1.5, since we're using upper real limits, and 10 respondents above 1.5. Therefore, the median is 1.5. Again, it's almost irrelevant what 5 or more means. They might get pizza three meals a day, 7 days a week for 21. Doesn't matter. In that case, I can see that the median is 1.5. And we leave people out on surveys like this. Like, let's say if I ask people, how many times have you been to the dentist in the last 10 years? The answer might be 0 for some people, just because, frankly, they're afraid of it. And in that case, I would leave them an out. Let's say, 5 or fewer if they don't want to admit 0. In that case, I cannot calculate a mean, but I can calculate a median pretty easily. And as you can see here, I can easily calculate a median. It's clearly between 1.5, or it is 1.5. There are 10 scores above 1.5 and 10 scores below it. And that's why we have that median, in case we have an arrangement like this, or in the case of great outliers like the number 12, etc. Now, with these outliers, you can physically calculate a mean. There it is, 76.71 or 4. But we prefer a median. Of course, in these cases with undetermined values and open-ended distributions, we have to calculate a median, have no choice.